let me draw a graph of Q T depending on T, and let me just show here the value of rainfall P, and you see that for changing value of T you get this kind of progress. First of all, for T equals 0, you have river flow equal to 0, so the graph passes from the origin. Now, for T that tends to infinity, you get Qt that tends to P. So you have an asymptotical tendency to the value of rainfall, and therefore you get, depending on the value of K, a progress over the hydrograph like so. So you have a progress from 0 asymptotically to the value of rainfall, which is reasonable. And the velocity with which the hydrograph tends to rainfall depends on K. If you have a large value of K, it means, let's remember what is K. K is such that Qt equal WT over K. Okay? If you have a large value of K, what does it mean? It means that you have a lower value of river flow. It means that the catchment is storing a lot of water. Because you see, if you have a very large value of K, you get at the same time lower value of outflow. It means for the same rainfall. So it means that W is increasing more. Because of course, if you have less water exiting the catchment, it means that you have more water stored in the catchment. So if you get a large value of K, again, the catchment is storing a lot of water and the convergence to rainfall is very slow. Because you see, river flow is lower. Instead, if you have a very small value of K, it means that the catchment is not storing much water, and you have a fast convergence to rainfall. Because what limits the convergence of river flow to rainfall is the storage. If you don't have any storage, you have the outflow that is equal to rainfall. If you don't have any storage, of course, you get an input of rainfall and you get at the same time an output of river flow that is equal to the rainfall input if you don't have any storage. And then you may ask me, what happens if the rainfall event ends? And then my reply would be, we cannot use this formula because I assume that rainfall is constant to bring it outside the integral. And if you want to know what happens at the end of the rainfall event, what happens when rainfall changes, you can't use this relationship here. This can be used only if rainfall is constant. Okay, and then let me finish by just saying one more thing. And to say this, I just bring back the integral form for varying rainfall, Qt. I have written that is equal to Qt star equal to the integral between 0 and T star of what? Of P T star minus tau, which multiplies 1 over k e to the power of minus tau over k in the tau. Let's ignore the contribution of Q0. What I have written, the second of the two expressions that I have written is this one. And let me remind you what I have written for the time area method in the same integral form. I wrote something like Qt star equal to the integral between 0 and T star, I said, of E, it was rainfall intensity, E T star minus tau, the A tau in the tau times the tau. You see that they are very, very similar. The structure, the general structure is the same. And in particular, final equation that I write, let me just write down the time area method in this way, and then just keep this relationship here and the one that I am writing, keep them there to discuss tomorrow. I can write it in order to get the same variable here. I can write it as P T star minus tau. And what's the difference between P and I is just the fact that P is given by I multiplied by A, if you remember, which is the area of the catchment. And then I can just write 1 over A here, because I want to write this second relationship by using the same variable P for rainfall, not I, in order to be able to compare that. Okay, so please keep this one and this one. And you see that they are similar. I'm not discussing the difference. Let me discuss tomorrow. And I just would like to say that today, as you have seen, I changed from a descriptive lecturing to a more analytical lecturing. And I wanted to start with a topic that in principle you already know, in order to be more gradual in changing from a descriptive to a more analytical treatment. And if there are problems, because I understand that with the English, my English is not perfect, so, and with the English there might be some problem. Let's discuss tomorrow about this, okay? If you missed something. Okay. Thanks.